And you're on.
All right. Afternoon, everybody. W2NDG here in what I call the compound in Highland, New York, in New York's Hudson Valley. Last year when we did this, we had only recently moved in here. I'm still in my office here, which is also my shack for now. Over my shoulder, relevant to this discussion, is the 7-inch Pi terminal that I'll talk about later. This is a self-contained Pi 4 in a 7-inch touchscreen box, controlled by a little wireless keyboard trackball combo. So that sits up here, and it's scrolling away with FT8, and that's live, running off of a Hans Summers QDX radio, just receiving. We're not going to be transmitting today. First, I want to mention, and I apologize for the redundancy, those of you coming from the FT8 talk, but I speak on a lot of different topics. And you know, the joke for my friends up here and my former fellow club members down on the island when I lived there is that I do this because I like to talk, and everybody knows that. But I like to talk on a variety of subjects, things that I know something about, but I will tell you, I'm never by any means the foremost expert on the subject that I'm talking on. If I don't know the answer to a question you've asked, I will try to get you the answer and post it on the website or email it to you if you email me the question. So, but I do love teaching, and that's what brings me to these things. I like to mention, I think that ham radio in general has entered a really amazing age. And it's that merger of computers and radio, two of my loves, that got me into ham radio about a decade ago. People ask me, because I also work in technology, you know, what brought you to what you do? Why do you do what you do? And I work in technology because every day there is at least one thing that makes me say, wow, that's cool. So, and it's what I'm good at, and I like making people happy when I fix things and make things work the way they want them to. So let's go here. I'm going to start the presentation. All right. So we're going to talk about Raspberry Pi, and not from the culinary point of view, but what it is, where it came from, what you can do with it, and what you can do with it that's ham radio specific. So who am I? I mean, I talked a little about where I am and what I do, but I'm an IT professional. I work in the technical side of cancer research. I've been in IT for 22 years. Originally got my license in 2011. I was a shortwave listener as a kid and up until 2011, and still am, although there's less to listen to. We currently live up here in the Hudson Valley. Spent about a decade on Long Island, but I'm from here originally. You can email me at, this email works as well, W2NDG@radiokitguide.com or Neil@neilgoldstein.com. I have a website, neilgoldstein.com, which we'll mention again at the end because it's where all the information from this talk is posted. And I maintain a webpage called radiokitguide.com, which covers one of my other passions, which is kit building. But we did have a poll, Gary. We had one in the previous session as well that I completely forgot about. I don't know if we can run that now or not.
Sure, Neil, let me find it.
Yeah, I forgot to add it to the presentation in the last one.
Okay, is that do you own any of the following Pi models?
Yeah.
Okay.
Should start with that.
Yep, sure. I'm going to launch that poll for you.
All right, so please answer the poll and then we'll continue.
Okay, Neil, with 90% of respondents answering, the overall majority, 63%, do not own any of the above. 25% own a Pi 0 2W. 18% I already own a Pi 400, and 8% own a Pico.
Okay. All right. Am I still sharing here?
Yes, you are. You're back.
Okay. Sorry. I've been moving things around. Okay. So we consolidated the poll a bit from last year, but it just gives me an idea of people's expertise and where they're coming from. So what is a Pi? What is it not? And we're going to talk about system on a chip, RISC versus CISC, history and models, layout, features, what can I do with it, and finally ham radio applications for it. The Raspberry Pi is, at its basic level, it's a computer, a very small, inexpensive computer. It has all the components of a larger system: input, output, memory, storage, audio, video, and more. A Raspberry Pi is not the same thing as an Arduino or microcontroller, but it does have some of the same functions. It has a GPIO bus for performing a lot of Arduino-like functions. So in some ways, it's the best of both worlds. You would still use a microcontroller for a very specific controlled purpose. And there are plenty of applications where a microcontroller is better because it's less apt to power problems and other introduced problems. A microcontroller is usually a very specific device performing one function that you've programmed it to perform. System on a chip is the practice of putting as much function of the computer into one chip as possible. Not just the processor, but all sorts of other things that would normally be in separate chips in a computer. And it allows for a very compact design and a very low power design. RISC versus CISC. So when we talk about ARM-based processors, which is what the Raspberry Pi uses, as opposed to Intel's x86 processors, RISC stands for Reduced Instruction Set Computing, as compared to CISC or complex, which is rarely called that. It's usually you're saying something is RISC or not RISC. It's more efficient. At 1 gigahertz, a RISC processor is a lot more capable than a 1 gigahertz Intel Pentium, let's say. Years ago, when Apple was selling their systems, their Macs, using RISC-based processors, they always had to remind people that, if you pardon the terrible pun, you couldn't compare apples to apples here because you weren't, that the megahertz comparison that their PC counterparts were constantly pointing to didn't really apply, because a lower speed ARM processor or RISC processor would outperform a similar speed x86 based processor. They were just more efficient. So in 2012, February, the original Pi was released to the public. The first goals were accessibility and education. Long time ago in Britain, the BBC, the British Broadcasting Corporation, subsidized a computer called the Acorn from Great Britain back in the 80s, right around the same time that the Commodore 64 and Atari 400 and 800, TI-99 4A, all of those early home computers were popular. The Acorn was BBC Micro's entry into that. And they supplied it with a lot of the tools to be able to teach kids how to write their own programs. This is what the original idea of the Pi was. In the beginning, supply was pretty tight, and there's been several revisions. The first model had originally less RAM, and they immediately changed that because they realized it needed more. A quick interruption in the Raspberry Pi hardware here. I wanted to mention that the BBC in the last few years has introduced another product, kind of as their own follow-up to the Acorn. And this is, again, a little SoC-based microcontroller style system that teaches kids how to code. Doesn't really have a video interface or anything. It's a much more simplistic device than the Pi, but it does have an LED matrix that allows them to create little games and be able to put out numbers or smiley face, frowny face, whatever the software requires, and on this little edge connector style card. This is version 2 that we're showing here. but these are cool and a good teaching tool. So there was also a Model A, which I don't really talk about much here as we go through, but Model A still exists. It originally did not have Ethernet. It only had one USB port, less RAM, but most of the other specs were the same. Why would you want this if it has so many less features? Usually power. If you were designing a board into an embedded operation or an experiment where you didn't want to use as much power, this is an option because the Pi does draw a lot more power than the corresponding microcontroller for a similar project would. So then we followed that up with the Model B, still with the same form factor here. And that original form factor was a full-size HDMI port and a composite port here, and a 3.5 millimeter connector that provide audio, and a full-size SD card. This is all from the original. This same form factor, but now we're getting a little better speed-wise. Well, no, I'm sorry. This is the original. Please excuse me. This is the original Model B. So this is the first one that a lot of people originally bought, including myself. In fact, I have a 256 meg one of these, the first one I bought before they decided to bump it up to 512 standard. I still have the original one, although I don't think I'm using it anymore. I was using it as a print server for years. But this form factor changed with the next revision, and this is the Model B+. This form factor stayed all the way up to the Model 4. And now we've gone to 4 USB ports, Ethernet, HDMI, which is not a full-size HDMI port. No. So still a full-size HDMI port. We'll talk about the other weird version of this when we get into the Zero model. But they've changed the power regulation a little bit with this one. They were having some issues with that. And we have the camera connector. And I believe that the GPIO bus grew slightly with this version. Still most of the same specs, but better form factor. This is the Raspberry Pi 2 Model B, and you can see we're still in the same form factor here, but now we've gone up to a 900 megahertz quad-core processor from the original. Analog audio in this form factor and composite video are combined into one 3.5 millimeter jack. So when we went to this form factor with the previous, we lost that RCA connector, which is fine. It took up a lot of space. This is similar to the connectors that you found on small digital cameras for years that gave you both audio and video in one connector. It's similar to that type. Pi 3 Model B. Now we're up to 1.2 gigahertz, gigabyte of RAM, Wi-Fi and Bluetooth. This form factor, which with the previous to it as well, also shrank that SD card down to a micro SD. Pi 3B Plus. Now we've gone to 1.4 gig quad core, still only a gigabyte of RAM. Most other things remained the same, but the Wi-Fi was upgraded, Bluetooth was upgraded, and now there's an option for power over Ethernet using what they call a HAT or add-on. Here's the 4. So this was the first form factor change we've had in quite a while. This goes up to a 1.5 gigahertz quad core ARM version 8, and now 2, 4, or 8 gigs of RAM. We have a choice. 2 USB 2 ports and 2 USB 3 ports. This allowed them to get the Ethernet faster, which couldn't be done before because the Ethernet was USB based. So it was limited by the speed of the USB bus. We now have dual video outputs, which have shrunken to micro HDMI. so you do need a special cable or adapter. Power changed to USB-C. Of course, Wi-Fi, Bluetooth upgraded. Still composite and audio in one jack, and still a micro SD card, but the form factor did change slightly. At this point, the Zero came out. This is a little computer board about the size of a stick of gum. It has 2 micro USB ports, one for power and one for actual USB use, which you need what's called an OTG or on-the-go adapter, which converts this to a full-size USB port. You can use it with a hub. It'll recognize that and get multiple devices that way, but the hub would be bigger than the device. These are great for embedded use when you really don't have a lot of space and a lot of power considerations. The video connector on the current Zero, and I expect maybe someday they'll change this to the micro, but it is a mini HDMI, which is kind of an oddball format connector that sits right between the micro and full size. Still micro SD card. You'll find these in a lot of little projects. One, for example, is the all of the digital radio hats for making your own digital radio hotspot. This is the Zero W, same board with added Bluetooth and Wi-Fi. There are ways in the Raspberry Pi OS to configure this completely headless. In other words, not having to add a monitor to it. There's lots of good information on how to do that, but a lot of the versions of the software that you can load on this and the Raspbian operating system allow you to pre-configure the Wi-Fi or even go into a special hotspot mode that allows you to get into the Raspberry Pi through SSH terminal and do your Wi-Fi setup that way and the rest of your setups. So you don't have to lug a big monitor or even a small one out into the field with you. You can do the whole setup without that, just over something like a laptop. And these have been $5 all along, even after they added Wi-Fi. This is one of the most recent additions to the line, the Zero 2W. Still the same form factor. There have been a couple of changes here. The previous model had a 1 gigahertz single core. So we've gone up to a quad core, but still only 1 gigahertz, same RAM. Basically, the form factor, everything here is pretty much the same except upgrading of Bluetooth and Wi-Fi, but they have taken the wireless components and put them in a little metal can now, which the shielding is nice, a little less RFI going out and a little less RF getting in from maybe a transmitter, which can cause these things to behave a little funny sometimes. Same size, same form factor, but now we're up to $15. This is the Raspberry Pi 400, which came out in advance of last year's session. They took the Raspberry Pi 4, a 4 gigabyte version with a 1.8 gigahertz quad core processor, and changed the board layout to make it more linear. You can see the comparison between what's inside of the 400 and the Model 4 here. And they stuffed this into a keyboard, and it has much better cooling properties. The 4 is known for getting pretty hot. I do recommend heat sinks with the 4, possibly even fans. There's plenty of little enclosures made that'll help you keep your 4 cool, but the 400 doesn't seem to need it. Much better passive cooling. We've lost the composite and audio jack, so your audio is going to come out through your HDMI system, or you can get audio out through the GPIO bus, or you can use a little USB sound card, which is how anything that requires audio in and out, I like to use those. It just makes configuration and setup a lot easier. Really nice though. And with the Model 4 in 4 gig and 8 gig versions, and with the 400, we're getting to a point now where we have Raspberry Pis that we can use as desktop computers. This doesn't really fit in with the rest of the products here, but it is a Raspberry Pi product and it's new, the Pico. This is a microcontroller, and it's the Raspberry Pi Foundation's answer to that part of the hobby. This is similar to an Arduino or a Teensy or one of those products. This is a specific purpose microcontroller, not designed to run a monitor, but you can build these for displays and anything else. There's lots of interesting projects for these. I do have one project for the Pico, which I picked one up, and it's on my long list of projects to do for my makers class. I have an e-ink, e-paper based project for the Pi Pico for a clock and weather display, which wirelessly receives information from either my weather station or online and posts it up on a nice e-ink display. And eventually I'll get to that. But these are cool and very inexpensive, $4. And there's already a ton of projects surrounding these. The other thing I usually don't talk about in my talks, but we're seeing them more and more, is the compute module. This is just the basic nitty-gritty processing portion of the Raspberry Pi, split off onto like an edge connector or riser connected card. So I say that you can design a lot of these boards into embedded use, embedded products. This takes that same idea to the hardware level, where you could design a whole system that this is the central processing and interface unit for. And if you see on this screen, this is one of the carrier boards you can buy for it, which basically takes the compute module and allows you to use it like a Raspberry Pi. But there's different ways to do this, and you can then interface these pins with whatever you need to. It's just a way of using a Raspberry Pi like we would use something like an Arduino or Raspberry Pi Pico. Definitely a lot more computing power here. Here is the Raspberry Pi 3 layout, and we already pointed to most of these items. The 4 with its dual micro HDMI ports and USB-C power. So what are you going to run on it? The main operating system that most people run on their Pi is Raspberry Pi OS. It used to be called Raspbian. It's based on Debian Linux, and it's compatible all the way back to the original models. You can get it in a couple of different forms, fully blown as a desktop operating system or as a light version. And there's also a version called Noobs, which is for people who don't have a lot of technical expertise. It's an easy way of getting the operating system onto your. Sorry, I had to mute for a cough there. There are other choices of what to run on your Pi. LibreElec, which is a Kodi-based system, or like a set-top box if you want to make your own Roku, so to speak. There's a few flavors of Ubuntu: desktop, server, and core, which is simply a no graphical user interface backend for running things. My early trials with the Ubuntu desktop found it a little buggy, but that was a few years ago. I haven't really tried it again since then, but almost everything out there as far as documentation and the projects are for Raspbian or Raspberry Pi OS. So I haven't really gone in that direction, but it may have improved. Retropie is kind of a pre-configured retro gaming system. And you'll see there's lots of projects all over the internet for taking the Pi and making a little game console. There's even plenty of cases you can buy where you can take a Pi and install it into one of these, and it'll look like a little arcade game when you're done. And this always shows up on the list. It's not free. It's only a 30-day trial. but for those of you in IT, a Pi is a great basis for making what's called a thin client or a remote, something you can run RDP or VNC or Citrix, other ways of getting into larger remote systems. So what are the limitations of a Pi? Because it's ARM-based, it'll only run programs that are compiled to run in that ARM environment. Now, ARM has become more and more popular, not just here, but across the industry. So there's a lot more written for ARM now, but not everything compiles for ARM in Linux. One in particular that I mentioned is the wine layer for running Windows programs really needs to run on an Intel processor. It won't run directly. There's been attempts to run it through some sort of x86 emulation layer. The one project that was going kind of fell apart because it just didn't work very well, but you can still kind of shoehorn it on here and make it work by using something like QEMU or Box. These do work. I can't show it right now, but I mean, I have a demo on my Android phone where I can actually boot into a box-based Windows XP install on my Android phone. So there are ways to get around this, but you may not want to do it. It's more of those because I can things. You're better off just buying a cheap Windows machine. And what about Windows on the Pi? So we originally saw in that list of operating systems years ago something called Windows IoT for the Pi. That's something that grew out of the original ARM version of Windows 8, which had been designed for the Surface, the original Windows Surface, not the Surface Pro, which was an ARM-based tablet. Microsoft kind of remixed it into the IoT version of Windows, which was not a full graphical user interface operating system, but it was basically, you know, a no front end, back end only system for creating Internet of Things or IoT interfaces. And it didn't really catch on all that much. But now that there's Windows ARM devices again, Windows will install onto ARM processors. There is an active group supporting methods to get this working. Now, this isn't official. Microsoft doesn't support it. It may be maybe even in violation of the Microsoft Terms of Service, but you'll find this out there, and you can get Windows 10 and now Windows 11 running on a Raspberry Pi. I wouldn't recommend it on anything below a Pi 4 with 4 gigs of RAM or a Pi 400. Android, still really not officially supported. Broadcom has never opened up support for its SoC to Android, but there is one Linux distribution out there, which is actually Android-based, Lineage OS. It's a remix of the Android for PCs that kind of marginally works. And once again, it's just more of one of those experiments, one of those because I can things. So people, a lot of times when I talk about the Pi, people will tell me, oh, I have a Cranberry Deluxe Mini or whatever. And it's so much better than the Raspberry Pi. Yeah, there's lots of other SoC boards out there that, and some of them can run circles around the Pi with what they're capable of doing out of the box. Some with M.2 hard drive interfaces on them, some with SATA ports, all sorts of things. Great. And in specific purposes, they're fantastic. Like the Kiwi SDR project, which runs on Beagle boards. A lot of us take advantage of those Kiwi SDR pages. Yes, there are definitely specific purposes for a lot of these boards. The Latte Panda, I don't know if it's still around or not, but that was a board, Raspberry Pi size board that ran real x86 Windows. But that's not what we're here for. Why do we use the Pi? Because it's a huge community. There is so much support and so much scrutiny of the product. It's been stable, it's been well supported. When they do have an issue, it gets corrected fairly quickly. And the amount of people who come out of the woodwork to help people get around problems and make the software work, it's just huge. There are definitely other things to look at and try out if you want to, but the Pi is where you want to be, especially if you're a beginner. So what can you do with it? let's get into this. It's basically a computer and will do almost anything a computer can do. It's not going to be as fast as most modern desktops, although Model 4 is pretty quick. You have the addition of the GPIO bus if you want to control things and make something more microcontroller-like, but here's a short list here. Small desktop computer, media center, music player, weather station, robotics, web-enabled controllers, education, remote cameras, terminal or thin clients, gaming, kiosks, small servers. I'll hit a couple of things here. Web-enabled controller. I had an idea to use one as a web-based crock-pot controller. So you could monitor a crock pot and kick it back to warming mode once the temperature or whatever you were cooking in it equalized. I have a friend who wanted to use one as a brew controller for home brewing. Same thing with some web interface. I do have a couple of pending projects, and I'll show you one because I have a test of it working, but the other one is for a stove temperature and clock display for my wood stove that'll read out the surface temperature of the stove, the flue temperature, and the ambient room temperature, and then the time and the weather and a few other things on a nice display. Put it up on the mantle over where the stove is. So there's certainly plenty that you can do, and just the ideas are endless. This is the camera in the picture here, by the way. But at the end of this list, ham radio. Well, that's why we're here. So there's lots of ham radio uses. We're limited to Linux programs that'll run on ARM again, as we covered before. And there's a lot more than there were when I first created this slide, but not everything. But most of the Linux-based ham radio applications have been ported to the Pi. There's still some things missing in Linux land in general. Some applications that people like to use. And there might be Linux alternatives for some of them, but they're not always quite up to snuff of the original. Echolink is a great example. There isn't a great alternative to Echolink in the Linux world. There are alternatives, but they can be a little buggy. But you can get Echolink up and running on a Pi for sure, including as a Echolink node. But for a beginner, it might not be the greatest path to take. Here's just a short list. ADS-B airplane tracking, which you can do with a RTL SDR dongle, remote SDR server, SDR radio, self-contained, but only from the Pi 3 and up. Are they fast enough to do this? Digital radio hotspot for DMR, D-Star, Fusion, and other modes. Echolink node, APRS, Whisper, antenna and rotator control, a TNC for packet, spectrum monitor is a great project for that. I used to demo one live when I did this talk in person. PSK31 terminal and others, which of course we're running the WSGX behind me here. And rig control, there's currently a commercial product for that, RigPi, and a transmitter. Let's take a look at what that means. So someone discovered back quite some time ago that some of the digital GPIO pins can be modulated at a high enough frequency to actually transmit RF. And what this first spawned was the Pi-FM project. This was a pre-made distribution that you loaded on your micro SD card, and you put music files, MP3s, and other common format music files in the root directory of the drive. And there was a config file, which you set up for playback mode and the frequency you wanted to transmit on. And with an antenna not much bigger than a paper clip, in order to keep it legal, you could transmit FM stereo music to FM radios in your household in FM stereo. They did the full setup with FM stereo modulation and everything. You know, that was really the first project we saw along these lines, and others modified this process to get other modes, AM, FM, sideband, digital modes out of the same thing. The output is not very clean and very low power. So, but even at low power, you do have to be legal. Your harmonics have to be below a certain level. And if you're transmitting FM and it's heard basically outside of your property, although there's very specific FCC rules for that, but you may get a call from an FCC representative. So you really want to keep this tight. But if you want to use this as something like a low power Foxhound transmitter or a whisper transmitter, you can install bandpass and low pass filtering on this to make it legal. And it works because the Tapper, Tucson amateur packet radio, sells a board that you can put on top of your Raspberry Pi that will transmit whisper, and it actually works. And once again, in the live version of this talk, I used to do a live demo of this. With some other minor changes, you can get other modes to come out of this. There's a little jumper you can remove on the board and software out there, and then you can run the receiving side of it on the same board and make yourself a little low power transceiver. It's clunky, but it works. The same board used to be available as a kit from qrpguys.com. Now it's available as a board only, but they used to sell this as a through-hole kit. Here's another project, Ian Lee, KDH-CEC, who did a lot of aftermarket work on the micro-BitX transceiver, has a project on his website where he interfaced a Raspberry Pi with a micro-BitX and created a little self-contained FLDigi and WSJTX box. Really neat. And this is kind of where the inspiration for how his new SBitX project, the direction that that's going in, I believe it's Raspberry Pi based. And for those of you who haven't heard of that, and if you're familiar with the UBitX or micro-BitX, we're talking about another multi-band transceiver that he's working on that's software-defined radio based and will put out about 50 watts. And the core processor on it that'll drive the radio and the display, I believe, is Raspberry Pi. Both the Web SDR project and OpenWebRX, which is the basic software that the Kiwi SDR was written on, will work with Raspberry Pi hardware for simple monitoring, single band, using something like an RTL SDR or other basic SDR hardware. And there's a number of Web SDR nodes that are running on Pis. TNC Pi is a special version of TNCX designed to sit on top of a Raspberry Pi and make yourself a little APRS system running on the Pi. You can make your own digital radio hotspot. This is a picture of mine. I ordered the kit version and soldered the headers onto the Pi, soldered the display onto the board, and you can make a full functioning digital radio hotspot running Pi-Star. This one ran me in the 40s and added the Raspberry Pi Zero to it. Works for all the common modes. Gives you some cross-mode capability, only between the similar modes like Fusion and DMR, but these work quite well. I've been talking about them quite a bit on the air in our local club up here, but come simplex, duplex, and there's other software other than Pi-Star, but that's the most common one. So we have enough speed to run the digital modes directly on these machines now. You can use a Pi 4 with a regular QRP radio or one of these new kits from QRP guys, CR kits, Midnight Design Solutions. I talked about them in the previous FT8 talk, but as I mentioned, over my shoulder here is my own terminal for this, running a Pi 4 on a 7-inch touchscreen self-contained box that takes the official 7-inch Pi touchscreen and lets you put it into a case with power connectors and active cooling. Has a little fan in it and a little hinged base, so you can set it to different angles. Really nice. Project called Ham Clock from WB0OEW. It's an active display of all sorts of information useful to the ham radio operator. This will run on the Pi as well as ESP microcontrollers, but it's really easy to get going on a Pi. There was a project, the project was laid out for the microcontroller version in QST, but on his website, he gives you all the instructions for getting it running on a Pi. And I also have a demo of that. So. Just going back for a second here. So here's an example of a commercial product that grew out of an open source Pi project. The Rig Pi, which I mentioned earlier, is sold by MFJ. And this is a Raspberry Pi based interface that you put between your rig and the internet to give you full rig control from outside of your home. And there are corresponding applications for your computer or your mobile phone where you can get into your rig and control the rig and talk. There are ways to do this without the Pi, and plenty of ways to do rig control, even open source free ones. But because this became a commercial product, it is a little more refined and maintained, and it works quite well. Here's something new, and this is on Crowd Supply, which is one of these funding sites like GoFundMe or one of those other ones. This is a project for the Pi. It's a hat or something that fits on top of the Pi on the GPIO bus. And this is a little dual tuner SDR device, dual channel, covers from 30 megahertz through 6 gigahertz. Both channels don't cover that full range. It's kind of split between the two, but overlapped a bit. Interesting project. I think the funding for this ends in 3 or so days if you want to get in on it. But they are over their goal level, so it looks like it's going to go forward. There's a Groups.io group called Raspberry Pi for Ham Radio. And just Googling Raspberry Pi ham radio is going to turn up a ton of information. If you search for that same phrase on Amazon, it brings up a couple of books. This is one of them, Ham Shack Raspberry Pi. There's certainly plenty of it out there. This is the Raspberry Pi specific Linux distribution called Ham Pi. Version 2, recently released, contains pretty much every ham radio app you could ever need. This was just a shot of the ham radio menu from the start menu here on my own version of it. I know these aren't readable. They aren't to me here either, but just gives you an idea of how much software comes on this thing. Really good. And once again, all these links are available. I'll show you where to get them. This is one that I just found when I was looking for updates for the other one. And there are some other Raspberry Pi based Linux distributions for ham radio, but these are the two that seem to be the most common. Luigi here has come up with one called Pi SDR, which is more SDR oriented, has more apps in the SDR frame, and there's a list here. There's a lot of stuff here for those of you who like to experiment and play with a lot of this. So also available. So this is posted at fofio.blogspot.com, or you can go to neilgoldstein.com, click on Fofio, and that'll bring you to a link to this presentation and all of the important links that I talked about. I think it's also going to be posted on the list of presentations, if it isn't already, after the fact up on the Ham Radio University site. So we're going to open up the questions real quick, and then because we can hang out a little later, since this is the final time slot here, I'll turn the presentations off, and we can do a couple of live things here. So first, let me turn the screen off for Q&A.
Okay, Neil, our first question up here is from Terry. Could you please explain why headless operation is significant?
Sure. So, I mean, we build a lot of things that you don't want to have a monitor hooked up to all the time. And a great example of that is the digital hotspot. Now, I meant to bring it in here so I could hold it up to the camera, but I forgot to. It's actually sitting out near the kitchen here. I put it in a central location in the house. But in the case of the digital hotspot, you're really never going to need to hook a monitor up to it. And it's kind of a pain in the neck because then you got to fish out your mini HDMI adapter, which is not a real common interface. And you're going to need a keyboard and a mouse. And with the Raspberry Pi Zero, you only have one USB connection. So you need like a combo device like this one that has a little trackball and a keyboard, or you're going to have to do that over Bluetooth or Wi-Fi, which you really can't do without being able to see the interface. So all of the control for something like Pi-Star is done that way. And you can change all of the aspects of the device without ever having to hook up a monitor. I'm going to share my screen again here real quick. And what you're seeing is the digital dashboard for my Pi-Star. And this shows the signals it's seen. And this is today, it's pretty current. And I can get into all of the various configurations, the admin page. I can upgrade the operating system and even upgrade my my hardware from here with firmware. So there's a lot of things you can do here. But when you first set this up, yeah, okay, we could put a monitor on it and a keyboard and a mouse. It's a pain, but I can do the whole thing over what's called an SSH terminal, which looks kind of like a DOS prompt, and get it going that way. And the two ways we can do that are by planting a little config file in the root directory of the Pi with the name of my Wi-Fi network and the password, and it'll automatically detect that and connect to Wi-Fi when it comes up, and then I can connect to that Pi remotely and do all the configuration without ever having to plug anything into it. Or in the case of Pi-Star and some of the other operating systems you can install on the Pi, if it doesn't detect a known Wi-Fi network after a certain amount of time, it will create its own. And you can take your laptop or computer and connect to that Wi-Fi network, and that gives you that same connectivity to the Pi, either over SSH or if you have it set up like this, a web interface or graphical interface, depending on the different operation you're aiming for. But headless is great because you know, cameras out in the yard. There's a project called the Pi Hole, which is a DNS trap for advertising that you can put on your network that blocks ads at the network level. All these devices, none of them require an interface. I would say think about your router on your network, which is all configured through a browser. You never have to plug a monitor into that. Same kind of thing. All right. Sorry for the long-winded answer.
No problem. While you have your Pi-Star open there, Foster would like you to re-explain who made your hotspot.
No, I made my hotspot, but it's based on one of the generic Pi-Star boards or the HS hat. You'll see the hardware listed here. Currently running firmware version 1.5.2. This is one of the ones I got off of eBay. You'll find them on AliExpress and Amazon as well. Some are better than others. I know there's an offset setting that you can do with these, but I did mine just simply by setting my transmit and receive off by 600 kilohertz here. Actually, less than 600. Was that 600 hertz? It wasn't off very far, but they mostly work. And the way I ordered mine was the HS hat board, headers, and a little OLED display. You have to solder those together, and that gets put on top of headers that you solder onto a Raspberry Pi Zero. And it came with a little metal case. You load it all into the case, and you load Pi-Star onto a micro SD card, which there's instructions on the Pi-Star website for that. Boot the thing up, and then our headless conversation comes in at that point. You do your configuring that way.
Okay, continuing along the same kind of topic here, Wendy would like to know where you recommend purchasing Pi equipment from.
There's a number of different sources for that, and reverting to the web page here, I do list a couple of places that are linked on the web page. It's our Newark Element 14, but if you have a micro center near you, even if not, they'll definitely ship to you, but it's a great place to go and get Raspberry Pi equipment. Adafruit has always been a great source, and there's the Pi Shop, both in the US and the UK. So those are some good places for that. There's definitely other places online that sell them. CanaKit sells their stuff through Amazon. And of course, when you buy stuff from Amazon, you're a little more protected if something goes wrong. But most of these sellers have a very good reputation.
Okay, we'll pull one more here and then you can get on with your demo. Let's see, Rocco would like to know what would you recommend as a complete, I guess, out-of-box setup to use as a hotspot Pi-based. And he would also like to be able to control satellite.
Oh.
I don't know what he means by that.
Well, that's a little different. Yep. So the hotspots are the digital radio hotspots, but for satellite control, I don't know if there is an all-in-one pre-configured one, and that's one of those questions I don't know the answer to, and I will look into that. I have heard of people using Pis for that, for satellite control, and I'm making a note of that. So if that attendee could email me directly by email, neil@neilgoldstein.com, or I think it's all linked in the presentation as well when you find me online, but and I can reply to you there. I can even post it on the website once I get that.
Okay, one more here. A couple people asked this. Where did you get the 7-inch touchscreen display in the back?
That is linked here as well. That is an Amazon item. Hold on. Here it is. It's right here. The Smart Pi is just the case. The screen I'm using is the official Raspberry Pi 7-inch touchscreen. It costs a little more, but I was thinking more compatibility when I did this. I really didn't want to be spending days and days trying to make it work. I've had disasters with the small 3.5-inch touchscreens where the configuration was terrible. The company that supported it only released one set of instructions, and as the Pi evolved, the display did not. I went with the official screen, and the Smart Pi 2 touch case is still available from Amazon, and there's a link here to the page, which you can see it's still here. $33 for this thing, which isn't really that bad. I forget how much the display runs, but it does make a really nice setup.
And is it 1080?
Hmm?
And is the resolution 1080?
No, it is not. Hold on. I'm forgetting what the resolution was. It was much lower. So you have to play some games with WSJTX to get it to fit, which you run everything with small fonts and the menu off, and you can get a usable screen out of it. No, it's definitely not 1080. It's much lower res. And once again, one of the things we're going for here when we do this is power. I don't want to have to lug a 30-pound battery with me when I'm operating in the field. So.
Okay, I guess we have time left for you to do your demo now.
All right, so I'm running, first let me kill the screen real quick. All right, that should have turned off the screen share. And just a couple of things on the camera here. This is the keyboard trackball combo I'm using. I do have a much smaller one as well, that I like to use with the Pis, but this one kind of fits with the size of this thing. I'll bring this down a little bit towards the camera so you can see what it looks like. And it's running WSJTX. It's been kind of scrolling contacts the whole time that we've been here. The receiver is a QRP Labs QDX, which has been running the whole time, but it may have actually quit because I was only running it on a 9-volt battery just for simplicity here. But this is what WSJTX ends up looking up like on this display. I have a better way for you to see it though. I mean, this is terrible to sit here and look at something like this. I'm going to share the screen again. I'm using VNC Viewer here to get into that same Pi, which I have referred to as Pi Console. And let me minimize everything else here. I can blow this up a little, but it is that same screen that you see over there. And you can see this is everything it's captured since I turned it on before the first talk here, the FT8 talk. And I'm gathering that the number of contacts has gone down because the voltage has been going down. Yeah, because it's currently tuned to 0 megahertz, which is out of band. Wow, you think? Anyway, but you can see what this looks like here. And I'm definitely getting a usable screen here from WSJTX. Now, I have this is another little feature they've added over the years, the menu checkbox. So you can actually get more screen real estate by turning off the menus, which is neat. All right, so let's quit this. There's certainly other stuff I mentioned in my FT8 talk about using FL rig in between your rig and the software you want to run. But all of this stuff runs on the Pi, as does FL-Digi, as does SDR software. I can run Cubic, which is probably the most robust piece of SDR software on here. But there's certainly plenty that can be done here. Here's FL-Digi. I'll show you what that looks like on here. And there's some tweaking of the interface you can do in these setups. Another little thing I've done here, though, is when I talked about the ham clock, I've set up the Raspberry Pi version. If you want to see what that looks like, we can do that right here. And you can go to the setup screen if you want right off the bat. We're not going to. And here it's just showing you the startup process, but you can skip this. It's connecting to a time server. It's checking all the different ones. Yeah, some of them aren't getting a response. And this is what the ham clock looks like. And you can change things here. So I have a UTC indicated up here, local time here. So like this one, for example, if I click here and I can change the time zone by clicking on an area. I had it set to California, 3 hours behind us. You can change the type of map. Here's just, this was the default, a terrain map. You can see your day-night line. I haven't really dived into the DX cluster functionality here, but it's showing some DX catches. And the country display is also pretty nice. Let that load. There you go. So This is pretty nice. There's solar weather here and a few other things. I just thought it was cool. And you can build this as a little standalone device. You could use this enclosure to do it, and this display. It obviously works, and works quite well. So neat little thing to have in the shack. I think, yeah, all priced out. You know, if you do it with this type of setup, probably a little over $100 for all of the hardware if you don't already have the Pi. A little cheaper if you do it with the ESP microcontroller, but a lot more work. All right, let me turn off the screen. I don't know if we have any.
Okay, thank you, Neil. Thank you for presenting this year again at the HRU 2022.
All right, you're welcome. I appreciate everybody coming by today, and feel free to poke me with questions, and we'll see everybody next year. For you local Hudson Valley hams, I'll see you soon.